In this video, we will take a look at weighted voting. In this topic, each individual or entity casting a vote is called a player. All right, kind of a funny word there, but that's what we're going to call them. Each player is given a weight, which represents how many votes that they get. So an example is maybe I'm in a weighted voting system and I might be player number 2, often denoted as player 2 with P sub 2, and I'm assigned a weight. Maybe I'm given a weight of player, but notice I put a number 2 there. Maybe a weight of 7. That means that when I vote, my vote is worth 7 votes. And the weight can be anything. It could be a weight of 1, 2, 3, 4, 5, 6, 7, up to 50. It could be 100. It could be anything, as long as it's a whole positive number. So that just means that when you get a weight, that just tells you how many votes you get. So then the second thing we have here is something called the quota. The quota is the minimum weight needed for the votes or weight needed for the proposal to be approved. Okay, so if we have multiple people voting on an initiative or a proposal, the quota is what we will call the number of votes needed for it to pass. So let's take a look at some of the shorthand for a weighted voting system. So what we do is we use a square bracket. We list the quota first. That way we know how many votes are needed. And then we just list the weights of the players. I would do the weight of player 1 first, all right? And then I would do the weight of player 2 next, and player 3, and so on, up to the number of players. I'll just say weight n if I have n players in the system. So typically we will use lowercase q for the quota, and we'll use W sub 1 for weight 1, W sub 2 for weight 2, W sub 3 for weight 3, so on, up to the number of players that we have. But what I would like you to remember in this shorthand is that the weights go in descending order. Go in descending order. That word descending means from the largest to the smallest. So you always want to list the largest player's weight first. Let's take a look at some examples of this to give you a better idea. All right. So this says, this is about the Council of the European Union prior to 2004. The following weighted voting system was used in the European Union Council prior to 2004. And this weighted voting system that you can see, the quota is listed as 62. So you need 62 total votes to be able to make something pass. If somebody says like, oh, I propose that we, build this new river. Okay. A dam on the new river. Okay. Oh, fine. So let's take a vote on that. Well, maybe some people are in favor of building a new dam for power, or maybe for water storage, but there's a number of people that might be opposed to it. Usually something like environmental oppositions, or some local entity that doesn't want to do that. But you would need a total of 62, and there's lots of ways you could get that. For example, if you got the first three players to vote yes, that would already be 30 votes. 10 plus 10 plus 10, right? You could do that, but that would not be enough to pass an initiative. Maybe you get player number 5, which has a weight of 8, right? You're up to 38. Maybe you get 2 of these 5s, right? And that's 48. Maybe you get both 4s, all right? And I'm already losing track of what I said, so let me just add these up quickly. 30 plus 8 plus 10 plus 8. We're now at 56. Still not enough, right? We have to get 62 votes. So if I get both 3s, I'll add 6 more votes, and that would be 62 votes. That would be enough. Notice that would be quite a few players, right? That's how a quota works. A, find the total number of players. Okay, that's just a matter of just counting them one by one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 players in this voting system. That's the answer to A. Find the total number of votes. That would just be the sum of all votes. So we would have to just add that up from the left to the right. 10 plus 10 plus 10 plus 10. That gives us 40 there, plus 8, plus 1, 2, 3, 4 5s. All right. Plus 2 4s, plus 3 3s, and a 2 gives me a total of 87 votes. All right. Part C, find the weight of player 6. Remember, these go in descending order, but the first player we call player 1. So player 1 is 10, player 2, player 3, player 4, player 5. Player 6 has a weight of 5. And then D, find the minimum percentage of the votes needed to pass a motion. Well, in this particular example, we need 62, right? We need 62 out of the total 87 to pass a vote, right? That's just what you do is you put the quota over the total number of votes, right? That's where that comes from. Grab a calculator and divide. 62 divided by 87, you're going to come up with a decimal. I'll do that on my calculator, and I get 0.7126436. I'm going to round off to the third decimal place. I'm going to call it 0.713, all right? Approximately 0.713. Remember, if you want to convert a decimal to a percentage, you can either just move the decimal place twice, or a nice way to think about it is, since a percentage is out of 100, you can just take that number and multiply by 100. So if you take that decimal that you have on your calculator, multiply it by 100, you should get 71.3, and that means we need 71.3% of the votes. That's a pretty big number, right? That's much more than a majority being just over 50%. Let's take a look at a last example here, and I'll get you involved just a little bit here. So this says, consider the weighted voting system where the quota, we don't have that decided yet. That's unknown to us at this point, all right? The quota is unknown, Q. We're going to list it as Q, but the weights are given as 10, 6, 5, 4, and 2 in descending order, all right? So my first question to you is, what is the total number of votes in this particular system? Pause for you to get an answer to that. All right, and then what would be, if you think back to previous things we've studied, what would be considered a majority here? This is going to be important for us in determining a quota. Remember, a majority is greater than 50%, more than half, right? So take a moment to calculate that. That's also a review question. All right, so then the questions for us here, after you have those solved, hopefully you have those solved and written down. A, what is the smallest value that the quota can take? Well, the quota has to be greater than or equal to a majority. And so there's a lot of reasons why. Why does it have to be greater than or equal to a majority? Well, if you have a quota that's less than a majority, it really won't make any sense. Let me give you an example of that. Let's pretend that the quota was actually equal to 12. It would never be. Hopefully you've solved your majority. You know it's bigger than 12. All right. But here's why it can't be 12. Imagine if it was 12, right? This is just a dream. Then notice that if we took the weight of player 1 plus the weight of player 5, the weight of player 1 is 10, the weight of player 5 is 2, we would get 12. So that means that just those two players alone could say yes to like any initiative, you know, anything that they were proposing. But if you took the weight of the other players, if you add up the weight of player 2 and player 3 and player 4, that would be 6 plus 5 plus 4. That would give you 15. That would be more than the 12 that voted to pass something. That would not make any sense to be able to pass a vote with 12 yes votes and 15 no votes. It should actually not pass because you're having more people say no than yes. And that's why that's not possible. Our majority must be more than the total number of votes. Excuse me, I said that incorrectly. Our quota must be greater than or equal to the majority. All right. Question B, what is the largest value that the quota can take? Well, it can't get bigger than the total number of votes. So that must be the answer there, the total number of votes. So, you know, if you look at the voting system we have here, if you've already found the total number of votes, and hopefully you have, you can see that it's impossible for us to receive 100 votes. There's no way. So our largest value possible is that total number of votes. And C, what is the value of the quota if at least 2/3 of the votes are required? Now that phrase at least means greater than or equal to, right? So it could be equal to 2/3 or more. So what we need to do is we need to calculate 2/3 of the total number of votes. And the way that that's done, you can use the calculators to take 2/3 times that total number of votes. All right, and use a calculator for that. So one easy way to do that is if you just think about it as 2/3 times the total votes. I'll just put TV total votes over 1, then you can just multiply straight across the top and get an answer here. Multiply 3 times 1, get 3 here, and do the division, and you have some answer. Now, if it happens to be a whole number, then you have the answer. If you don't get a whole number, you'll need to round. All right. And that's kind of how you can find a fractional number of votes. 2/3 is sometimes used in a lot of systems as a fraction that's necessary to pass something. So that's why that's used in this particular case. I hope these examples have provided some clarity on weighted voting.